start with some questions. Sophia?
So, a problem. You just do, I said number 4.
On which, the problem set, the worksheet 1 or worksheet 2? Okay. Because there's like 3 number 4s, right?
Yeah.
Sure thing. All right. So, first thing I'm going to observe in the directions, it's asking me for an exact value. On a problem like this, when we're asked for an exact value, what do we know we're going to have to be using? Unit circle. Second thing I'm going to observe is that my thingy cut out. Thank you. Is that I'm not given an interval in which to find my angle at, right? In that case, what do? We use the fundamental range for the tan inverse function, right? So that really is going to be from negative pi over 2 to positive pi over 2. So this is quadrants 4 and quadrants 1. Tangent is negative in quadrant 2 and quadrant 4. So we're looking in quadrant 4. So the theta that I'm looking for should give me, or should have a y over x, because that's tangent, equal to negative root 3. So let's go look at our unit circle. Let me grab a copy of that and drop it in here. Whoop. Whoop. I'll just put it right there, I guess. So in quadrant 4, I'm looking for a place where the y coordinate has a square root in it. That would be right there. So I have, if I go back then, add, what is that? 5 pi over 3. Is negative root 3 over 2 divided by 1/2. The denominators of 2 cancel out. And that does give me the square root of negative 3, or negative square root of 3, excuse me. So I have the first piece taken care of, right? What I don't have, though, is my angle inside the correct interval. 5 pi over 3 is not between negative pi over 2 and positive pi over 2. What do I need to do to it? Find something coterminal to it that is between those two angles. Is it too big or too small? Too big, so I should be subtracting 2 pi. So 5 pi over 3, if I subtract 2 pi from that, that's the same thing as subtracting 6 pi over 3. That should give me negative pi over 3. Alternatively, Sophia, if you looked at the picture here and said, oops, okay, that's my spot. I just need to go that way. So if I'm starting at like 2 pi and I'm going backwards to 5 pi over 3, negative pi, pi over 3. Or you could even think about it forwards, from here to here is positive pi over 3, but we really want this direction, so it's negative. Either, you can just look at the picture and figure that out too. Yeah, absolutely, no problem. Diego. On the problems? Okay, 14 you say? Absolutely. Okay, this is cosine of 2 arctan, or arcsine of 1/2. So the 2 there is really 2 times. So I'm going to start here with arc sine of 1/2. I remember the fundamental range for sine is here. This is quadrants 4 and quadrant 1. Sine is positive in quadrants 1 and quadrants 2. So what I'm looking for is something in quadrant 1. Cool with that? Sine is the y coordinate. So I'm looking at pi over 6. Cool with that? Okay. So I have then cosine of 2 times pi over 6. 2 times pi over 6 is pi over 3. And when I go do cosine of pi over 3, that's the x-coordinate pi over 3, which is 1/2 again, which feels like it should be the wrong answer, but it's definitely not. Yeah, of course, dude. Giselle.
Could you just like explain what you want for number 15? I just was like confused what it was talking to.
It's just like worksheet 2.
Oh, okay.
I mean, you can do it. I mean, it says use your calculator to do it, the graphing feature. So like, so all this is really saying is, okay, I'm going to graph tan theta and find out where that's equal to 1.3. And then my window, I'm going to go from pi to 3 pi over 2 as my x min and my x max. I guess I'll just set that from -10 to +10. This should be fine. So I'll hit graph. So here's my tangent function. Here's my line. And I'm just searching for the intersection there. So second trace, intersect command, enter, enter, enter. So 4.06. Ballpark.
Do you do it the other way? Like,
Yeah, you could do it the same way you did in worksheet 2. That's fine also.
Okay.
You're accomplishing the same thing. It's just like another way to do it. All we're doing is graphing and finding the intersection. You're welcome. Ava?
Can you do a problem on worksheet 2? And then,
Absolutely.
explain how to know like you have to subtract or add?
Absolutely. Sure. Do you have one in mind?
No, I just don't understand what adding subtract.
Okay.
So just like
Does someone else from worksheet 2 have a problem they're interested in? So we can like do 2 questions for with the power of 1. 2 birds, 1 stone. Anybody want to be my second bird?
oh, wait.
3. That's a great bird. Thank you. Make sure you make your bird noise though, okay? Let's hear it, Tommy.
I'm a bird noise.
Oh, that's unfortunate. All right, Ava, here we go. So this is the same thing as thinking tangent theta is equal to this, right? Now, tangent, I remember, is y over x. So I'm going to use that to figure out what quadrants tangent can be negative in. So for a fraction to be negative, either the numerator has to be negative and the denominator positive, or vice versa, right? So that would be quadrant 2, where the x is negative but the y is positive, and quadrant 4, where the x is positive and the y is negative. So I'm going to do this in like painstaking detail. Is that good?
Yeah.
Okay. Yeah, of course. All right, next thing I'm going to do is figure out what two quadrants that interval is covering. So I notice the values are positive on the angles, so I'm going to be rotating which direction? Counterclockwise, to the left, right? I should say to the left, correct. Saying to the left, right is unintentionally too confusing. All right, so we start at 0. This first spot is pi over 2. So starting there, that's pi, and then ending here is 3 pi over 2. So the two quadrants we covered were quadrants 2 and quadrants 3. So I know my answer lies somewhere in quadrant 2, since it's the place where both of them are true. So that's my theta. That spot is pi, and then I'm going to worry about that angle phi in between them. Okay? So I now need to create an equation relating pi, phi, and theta together. To do that, I'm going to compare the size of theta with the size of pi. Is theta bigger than pi? No, because it stops before it gets to pi, right? So I know that I should be subtracting from pi to get theta, because theta is less than pi. So I should need to subtract something from it. What do I need to subtract? Well, phi. That's the rest of the way to get to 2 or to get to pi. Cool with that? Once I've done that, it's calculator time. So the way I calculate phi is I'm just going to take the inverse function given me to the problem, but I'm going to do it with the absolute value of the inside. Double check to make sure my calculator's in radian mode. And then we're just going to do, in this case, pi minus, tangent inverse. And I'm not going to bother typing in the absolute value. I'm just going to do the absolute value in my head. Everybody's okay with that? It's like a lot of extra buttons. So I get about 176. Is that okay? So to decide whether it's addition or subtraction, I'm just going to be looking at, did my angle pass the horizontal or not? Okay. Right? If it just passed the nearest horizontal, then it's adding. If it hasn't yet passed it, it's subtracting. Unless what? The angles are negative, right? So let's look at one of those. Is that good here, Ava?
Yeah.
I don't think there's any negatives on the first page. Let's grab one from the second page. Anybody got a favorite from the second page you want to see? Ava, it's on you then. Great choice. All right. So again, we're looking where sign is negative. That's quadrants 3 and 4, right? And then here, we got to be going, since these are negative, we're going clockwise this time. So still we're starting at 0. This is negative pi over 2. And then starting there, we go to negative pi, and then negative 3 pi over 2. So that's quadrant 3 and quadrant 2. So I need quadrant 3. So there's my theta. This is negative pi. And that's my phi. Now I have to be careful. Is theta bigger or smaller than negative pi? No, it is bigger because we're dealing with negatives, right? Like negative 0.5 is bigger than negative 0.6. Ugh, right? So that's the only hang up. So here, it doesn't look like it should be smaller. Oh, it doesn't get there. But because they're negatives, right? So we should be, in this case, adding, since theta is bigger than negative pi. But everything else, I mean, it's the same kind of setup. You just have to be careful about, like, what does bigger and smaller mean from the picture? Because you have to remember, like, you're dealing with negative numbers, so it's like everything is cuckooed, you know? But otherwise, it's okay. So again, we just do, for that phi, is going to be sine inverse of the absolute value of negative 0.56. And it's calculator time. So negative pi plus sine inverse. And then again, I'm just doing the absolute value there in my head. And I get negative 255. Does that feel okay? Yeah, so again, it's just looking at the picture is all I'm doing to figure out whether I should be adding and subtracting. And I think that like it's hard for me to screw that up once I have something to look at because I can really just like, is this word, is this right? And then keep in mind, folks, once you have your answer, it's pretty easy to check this. So there's two checks I need to do. I need to check to see if sine of this answer gives me the negative 0.56, which it does. And then I need to check to see if negative 255 is in between negative 3 pi over 2 and negative pi over 2. So bigger than that one, right? Negative 255 is bigger than negative 471. But it has to be smaller than that one, which it is, right? Negative 5 or 255 is less than negative 157 or whatever that is. So again, you can check every single one of these with your calculator just by doing the same thing. You just make sure that you're getting the right values and that it's in between the two places. And I just had to check if it fell in the interval, so it has to be between those two numbers, which it is. Right, negative 255 is in between those. We're doing 7. My answer was negative 255. I had to make sure it was in between those, and then when I did sine of that number, it gives me the negative 0.56, right? So easy to check them. They're all checkable. Should not get to one of these and be like, oh, I don't know if that's right or not. Check it, you know, unless you goof up the checking, but like, come on. That's pretty tough to do. Sophia. Yeah, sure. You got one in particular? Okay, let's do it, Rita. 11. Sure. Sure. I have this hoarse voice that sounds like I'm a teenager again. Do you kids still watch The Simpsons? I feel like that guy, that the teenager that's always working is like the clerk at all the stores. He's like, "Hello, Mr. Simpson. Can I help you?" And my voice is just kind of all over the place.
Why is that?
I think I had like a cold. It just feels like I'm a teenager again, where my voice is cracking all the time. Does that ever happen to you when you have like a kind of lost your voice? Yeah, that's where I'm at right now. It's a lovely day. I actually feel better than I have the last like 3 or 4 days, which is nice, but I sound worse. So you figure that one out. All right. Tangent is positive in quadrants 1 and 3. Cool with that, Rita? Okay. And then between 3 pi and 4 pi, well, again, they're positive, so we're going counterclockwise. So starting at 0, that's 1 pi, 2 pi, 3 pi, And then all the way to here is 4 pi. So we did quadrants 3 and 4. So the answer I'm looking for needs to be in quadrant 3. So I'm going to go to my unit circle and look for the place where y over x is equal to square root 3 over 3. Now that's going to be a problem if I go to try to look at my unit circle, because I know there's no regular 3's anywhere in any of the coordinates on my unit circle, right? So here's the way I'm going to think about this. I'm going to reduce this. 3 is the same thing as like the square root of 3 squared. So I can just kind of reduce. So I'm going to be looking for that. Basically, I'm going to go and say, okay, I'm looking for a place where the x coordinate has a square root of 3 in it. That's was probably the hang up, I'm guessing. Yeah? So if I go and I do that, where's my unit circle? I had it on here somewhere. There it is. So in quadrant 3, where the x coordinate has a square root of 3 in it, there's my spot. So I have 7 pi over 6. So far, so good? All right, so scroll back over there, all the way over. So I can say tan of 7 pi over 6 is equal to negative 1/2 over negative root 3 over 2, which does give me the 1 over root 3, which rationalizes to root 3 over 3. So I have the first part. That works. But what's my problem? Not big enough. What do I have to do? Add 2 pi to it. So that's 1 1/6. If I add 2 pi to that, that's going to be 3 1/6, which is in between 3 and 4 pi. Cool with that? That's just me verifying that this answer is correct without having to type it into my calculator. Is this cool with you?
Yeah, I got this answer, but I don't know what was on the sheet.
Oh, did I just screw the key up? I might have.
Yeah, it's like
11 pi over 6 instead of, I think,
Yeah.
Oh,
I think that's why I took.
I just grabbed the wrong quadrant or something. That's a dumb move, Mr. Kulik. Let's look at the key real quick. Let's change it right now.
Yeah.
This was on worksheet 1.
Yeah.
This was number 11.
Yeah. It's in 23 times.
Yeah.
So I just wanted to.
Yeah, that should be, what do we say, 19. Okay. Thanks, homie.
Yeah. So. Oh wait, yeah. It's supposed to be 7 times. Like.
Oh, yeah. I did the other part right, though. Just wrote down the wrong one initially. Okay. Yeah, thank you for noticing. All right. Any more homework questions? Okay. Let's take 20 minutes or so and do the next section real quick. And then we'll do this homework quiz to finish her out. Sound good? Here's the good news. This is like, for the most part, pretty easy stuff. So I just have a couple of examples and like 2 vocab terms, and we are Audi 3000 here. All right. All right. Let's talk about these two terms here, angle of elevation, angle of depression. This is something you would have talked about in your geometry course, but Mr. Kulik remembers that geometry was a long time ago. I'm just going to describe this with a picture. So let's say we had one person here down on the ground, and then another person here that's like up on the top of a building. Okay? So if this person looks straight ahead, this is like their normal line of sight. Agreed? If that person looks up at the person above, that would be your angle of elevation. Everybody agree with that? Okay. Now, if the person up on the building looks straight ahead, this would be like their line of sight, right? If they turn and look down, this angle here is an angle of depression. Everybody cool with that? What mistake do you suppose students make? Is you put that angle in the triangle as the angle of depression. Not the same thing. Right? Is you just put, when we give you an angle of depression, you put it in the triangle where I put the star. That's wrong. What do you notice about the angle of elevation, the angle of depression in this situation? They're congruent. Why are they congruent?
Because they're like the same. They have parallel lines.
They're alternate interior angles.
Yes.
Yeah, you have two parallel lines cut by a transversal. That's probably the T word you were thinking of. Alternate interior, I think, is that was the vocab we used when I was in school. Your textbook might have called them opposite interior. I don't know.
It's the same.
It's not.
So if I just go inside angles,
I'm just reminding you guys for some vocab.
Call me.
I'm gonna call them inside. Inside alternate.
All right. Let's do a couple of do an example with this anyways. Christy is looking up at the Fisher Building in downtown Detroit. She's standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the Fisher Building? Okay, what can we say about a building in the ground? Create a 90-degree angle. What's the one time where this would not be true? Or we know not to be true? Leaning Tower of Pisa. Yeah, those darn Italians building on unstable foundations. Okay. Any other building, you can just assume that, unless you're told otherwise, that it occurs at a right angle to the ground because, that's pretty convenient. All right. So the 200 feet should go here. We're looking for the height of the building. So that would be this side. We're told the angle of elevation is the 66 degrees. Where does the 66 degrees go? Angle SKX, right? Everybody cool? Okay, how do we solve for H? Go ahead, Carmen.
Well, solve for H, we have to find
find sine of if we use sine of 66, so that would
I mean, you can do what you're doing, but I would do something different.
oh never mind. So first you add all the interior angles of the triangle. So do 66 plus 90 plus angle S equals 180.
Okay.
So 66 plus 90 would equal 156. Then you subtract 156 from 180 and you would get 24. So angle S equals 24 degrees.
Sure. Got it. But do we really need this? It's true. What you're saying is not wrong. Do we need this to find H? Paul, you said you had an idea?
Yeah. Tangent 66 degrees equals 200 over H.
Yeah, relative to the angle 66, we know adjacent, we're looking for opposite. So we can just say tan of 66 equals opposite over adjacent. Multiply both sides by 200. And then it's calculator time, right? What do we have to be mindful with our calculator? Yeah, what mode does this need to be in? Degrees. So 449.21.
Okay. So you're just
You're fun to me. I did want to know would be Gus, not gonna lie.
I mean, clearly you guys are Pete and Badger. Let's be honest. You guys can fight over who gets to be who, but that's clearly who you two are.
Yeah, you're Steve. No, you're not. I'm the one who cries. You just gotta call the secretary.
All right.
I'm the one.
Next up says Jane has climbed a tree and is looking down at her friend Mary. Jane has climbed 17 feet in the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? All right. Yes. Oh my gosh. Where were you like 10 minutes ago, man? That's okay. Better late than never, I suppose, right?
Easy transition.
Like I noticed like that one's like
That was too clean.
I got it. It's an easy fix, guys. Boom. Look, there it all is.
Wow.
That was clean.
All right. So here's Jane. Here's Mary. We're looking down at us. Again, yes, of course. Again, tree and the ground, what can I assume? Right angle.
Yeah.
Most of the time that's the case. We know that Jane's 17 feet up in the air, so that side is 17. Where does the 49 go?
Up top. Right? I think.
Yes.
Angle depression.
Wait, when
You so here?
yeah, no.
Eh.
No, on the outside. On the
Who
outside.
said that?
This is where the 49 goes.
It was just there.
You tried to trick us.
Or where else could you have put it?
Down there.
Down here by the M, right?
So, up.
Alternate interior angles, homie.
I smell a candy.
Yeah, but why is it not like why is it outside?
Because that's the angle of depression, because Jane's face is here, she's looking, that's her line of sight, and then she looks down at Mary.
But then aren't they the same? What? Yes, aren't they interchangeable?
No, you'll get a different value.
But if you could put the angle for the
Stop talking so I can hear, please. Go ahead, Olivia.
The angle of depression with the angle of elevation is how like I get.
I'm saying that if you put the 49 here, that's wrong.
Yeah, no, I know. But
Okay.
like we're able to put the 49 where the angle of depression is,
Mm-hmm.
and then you moved it to where the angle of elevation is.
Those are alternating interior angles.
Yeah, I get that. But
Okay.
wouldn't they be like same thing? Like,
Yeah.
yeah. Okay.
Yeah, if you have two people, one's looking up and the other person's looking down, it's that they're looking at this, it's going to be the same angle, right? If I'm looking up at you, your angle of elevation better be the same as me looking down at you, my angle of depression. You know what I'm saying?
Yeah.
That's okay? Okay. And then we're looking for what? How far is Mary standing from the base of the tree? So that's our... So you're smelling another tangent, I heard. That's good. Relative to the 49, we have opposite and adjacent.
That's such a dog.
No, it's not. It's easier when it's the other way.
To solve, what do I need to do? No. Get rid of the fraction. Multiply by x first. And then we divide by tan 49. Right?
That's such a dog.
If you divide by 17 first, you're going to get 1 over x by itself. And then you'd have to do like the reciprocal of both sides or something. Which you can do, that's fine, but like Yakaruskis.
Dare I say that's
I mean, it's a common mistake to solve for 1 over x and just call it x instead. Again, I would say as a math teacher, I see that fairly frequently. So I get about 14.8 feet.
I agree on that. Second shows.
No, I don't.
Which seems reasonable, right?
It's like 14.
49 degrees is pretty close to making this a 45, 45, 90 triangle where I expect the leg lengths to be equal. So the two leg lengths being pretty close feels pretty good to me.
Is that 1.48? Oh, that's
14.8, yeah. All right. Okay. So super easy to hear, right? Been pretty easy. Just doing regular old like geometry level right triangle trig stuff. This last one gets a little bit tricky.
Not for me.
No, not for me.
Claude and Simone are riding bicycles in Paris. How romantic. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. Okay. Everybody cool with what I drew there? When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? Okay, everybody cool with what I've drawn? Tough though, right? What's the problem?
We don't know the base.
Yeah, we need this piece. But if I do that, I have the two right triangles I have here are this one equals opposite over adjacent, right? And the other right triangle I'd have is this one. And as Paul has indicated here, this is a screaming at me to create a system of two equations, since both of these two have two variables in them. I can write two equations with two variables. Yes, sir. Let's system of an equation this thing up. So what I would do is I would clear the fraction. So this first equation is going to be 100 plus x times tan 32 equal to h. And then this one would become x tan 37.5 equal to h. Yeah, so I can set them equal to each other now since they're both equal to h. I want to point out to you that this is going to be kind of the easier algebraic route, but like the longer step, because when we solve, we're going to get x. What are we looking for in the problem though? H. So that's fine though, we can do that. I would probably opt for the easier algebra and a little bit extra computation than crummier algebra and less computation. The computation's pretty, NBD. Everybody's cool so far? Okay. Got to solve for x. That means I got to get the x's all on one side. So I'll start by distributing that tan 32 through. Everybody good with that? I'm going to subtract the tan 32 to the other side. Or I'm sorry, the x tan 32 to the other side. Notice on the left-hand side, each of those have a greatest common factor of x. So I can factor the x off. This is now turned into a multiplication problem, right? So I can divide both sides by tan 37.5 minus tan 32. And now it's calculator time. I'd strongly encourage you to use the fraction command to do something like this. So alpha y equals and then option 1. Because it is a lot of parentheses rattling around if you're going to try to do this in one line without doing the fraction command. You know what I mean, dudes?
For real.
But this way I can just type it in exactly like it looks on my sheet of paper. So 438.64. Oops, 64. And then I can take this guy. So H is equal to 438.64 times tan 37.5. And that's 336.58. And I think we're dealing with feetsies. Even though we're in Paris, what should we be using? Le metre. That metric system. Olivia. Sure, Rita.
Wait, what's the very last step you did, like times the tan of 37?
I just plugged it back into one of the equations. Plugged x back into one of the equations to get the h. Right? So I just used that one. You could have used either one. That one was less complicated though, so that was the one I opted for. You know what I mean?
Yeah.
At this point, you guys can now do in the problem set numbers 19 through something or another, 19 to 23. And I think worksheet 3, yup. And again, that'll be stuff that'll be due on, what's it called at the 30th, Sunday.
Obviously.
Sound good, homies? Quiz time.